These are some more operations. So pre-processing in all means what? Your image must be normalized for recognition. It should be as simple as possible in any general type of application so that it can be easily recognized. It can be easily recognized. So all required parameters for recognition process are our final destination, identification, detection, recognition. So there should not be problem because of this initial parameter adjustments in latter processes or final processes. That's why we perform pre-processing. Most of times we keep inherent processes, even though there is a problem or not problem, we normalize the image so that further problem will be avoided. Our next image processing application or process is segmentation. Segmentation, in simple words, it divides part or divide image in different parts. Why we are doing this? Because we need to find where our object is. Because of color combinations, many times our object may be submerged in the image. This may not happen in industrial application where we are taking care of that. But in real life, whenever it goes on roads or it goes on real environment, at that time, every time we do not have ideal conditions. For example, in this image, you can see this is one tree and there is a one creature on the trunk of the tree. So right now, in this first aspect, we do not recognize it at all. But we know it is here because this is captured image. So what we have to do? We have to process part. So where is the creature? That is our region of interest. So this is primarily we divide this image. This is road, grass, and trunk. So object is on trunk. So we have to select that particular area. We have to select that particular area. So only trunk area we are selecting. Then we are processing. We are removing unwanted things and only that particular part will be highlighted so that we are detected this object. So how do we come to this particular object location? We come to this particular object location by dividing total image area or by segmenting the total image area in different parts. Another example of this is, suppose in this image there is a different types of textures are there, colors are there, shapes are there. So according to these parameters, we want to divide and we want to, suppose we want to highlight this text, then this is not, this area is not useful, this area is not useful, water is not useful, seashore is not useful. So we have to reach to this triangular area and then we have to scan triangular area where text is highlighted. Suppose race is going on and we want to detect which is the first. So to identify this, we have to reach to this area. So we are dividing all this area. Now question is how to divide that area. They are said as image segmentation techniques. Now simply image segmentation is that we divide in the regions, we divide in the different line segments, curve segments, polygons, circles. This is how we decompose overall image and we reach to the area of interest, that is the region of interest. Now suppose this is what one example we have done this practical in practical also. So now color based segmentation or texture based segmentation. So what we are doing, we are scanning this image, then every object is having its own color, every object is having, so we highlighting each object by its own or different type of color, and we are dividing them, then we can classify or do further operations. Second aspect is now segmentation based on texture. So this is what room scene, every object is having its own texture. This is floor, this is one sitting arrangement, second sitting arrangement, table, chair, many things, wooden objects. So we divide image in each part, and again each part can be separately assessed so that we can detect particular things for that area. This overall process to divide image in the areas or regions is called as segmentation. Now first type of segmentation method is thresholding. Here we apply thresholding technique which you have learnt in lab. We have conducted one experiment, or first part of the first second experiment, where you will find that according to brightness we classify, according to gray level we classify the image and the pixel areas. So we apply histogram, remove noise, and then we can divide image in different type of areas. Now suppose we have to divide circle and square, presence of noise will be giving you problems. Suppose high noise is there, now this and this may not have similar to like this. Because of noise, these areas are corrupted, so you can feel both are equal. So we apply histogram based segmentation where gray levels are there, so we can identify where is background, where is the area 1, area 2, likewise. So we apply histogram based gray level thresholding, so we can have different profiles. So background is there, object is there, depending on this we can apply threshold and remove that particular area, so object will come out. So just go through all these details. I will go ahead with gray level thresholding. Next is age detection based segmentation. In this case we find out different ages. First of all, what is age? Age means it is transition from white pixel to black or black pixel to white. If this continues for many pixels, then age will be formed. Age is a very important part of the object because age gives shape to our object. Age gives discontinuity in the texture so that we can understand that this object is different and this object is different, or at this particular line this object ends and this object starts. Age can be found out by different ways like gradient based images, or you can have Sobel operators which we have done in lab, Roberts operator. So various operators are there. You just go through textbook and go through this Sobel Roberts operator. These are performed in lab also. There is one more technique, canny edge detection. This algorithm also we have done in Python programming. We have done at that time we have learnt about this canny edge detection. Next part is now region based segmentation. Edge defines shape. So we find edges automatically we can find shape, and they can be the number of regions or number of objects can be separated. Another aspect is now, if I define regions, still I can divide image in different parts. This is how humans also identify shape. So we humans identify shapes on continuity, closure, discontinuity, lines. So various types of shapes we are deciding through this particular edge operations. Okay. Now in region based segmentation, we are finding homogeneous regions. Many times noisy images are there. In that images, this will be very effective. Edge detection, you find edges and then you have to define the regions. Sorry, the shapes or regions. In the region based segmentation, we divide regions and every region emerges out, it comes out in front of you. So edge based segmentation assumption is that objects can be separated by their edges so that shapes will be defined. So there are discontinuities in the object, so we can say that they are edges. In region based objection, you can separate by their perceptual boundaries or neighborhood. That means in a particular object, if I am getting similar kind of continuity, then that is homogeneous region. In our normal texture or in mechanical engineering, whenever we check surface, you know that if the surface is having continuity, then that texture is similar. In the image also, if you are getting similar type of properties, then that is part of one region, and when it is changing, it becomes second. So region is most often on texture. On the contrary, the edge based detection is based on edges or the color changes. Now there are four techniques of edge detection: region growing, region merging, region splitting, and split and merge. Actually, computer is looking at images. That means it can see what are gray levels stored in that image file. After a header, there will be sequence of image gray levels in that particular image file. It depends on your file is monochrome or RGB. We have learned this part in lab. Now in region growing applications, we are collecting. It is first of all iterative process, right? Then we give certain seed, that is what starting point, and then similar gray levels will be accumulated. So we collect similar gray levels and merge them and form one area. So we grow a particular region by collecting similar part. See now, this is what seed point, and now similar gray levels we will be increasing and developing that area. So seed pixel will be starting pixel, and then in what region similarity we are getting, so that is direction of the growth of the region. Now in this example, look at here. So my 60 is the gray level given. Now what we do, we will have a threshold. Let's say 60 to 64 is the region. Then 60, 64, 69, this can be one region. 65, this can be region. 10 may not be part of this region. So by joining these points, I can define a particular region. These all becomes one region, right? So you can see 60, 69, 64, 60, 65, 67, 59, 70, or this complete line. On the contrary, 10, 10, 10, all 10s are equally. So this is age. Here also age. Then we can have another. Likewise, we can apply thresholds and divide overall image into different regions. Where regions are growing, because we are collecting similar property, similar gray levels together, so region grows. Now region merging, in this case, after seed pixel, we start merge similar levels. So what we will do, we will be merging these levels together so that this becomes single region. So we try to merge this area, this particular part. In an earlier case, we just add them and connect a border or connect, so region was emerging. In second case, we add similarity criteria. Who are the similar? We merge them together. So 60 to 64 are similar, then we merge them together. Earlier case, we select. In region growing, we select, so region grows. Here we merge them and they can be part of one region. Similarity criteria can be gray level, color, texture, shape, model, and region merge technique can be used very efficiently. Next part is region splitting. Now based on gray levels, we straightaway classify, straightaway divide. So what is the gray level and where it will be there? So we classify on the similarity criteria. So these and this image is part of R1. So simultaneously we perform operation and we select. On the contrary, earlier two operations, pixel by pixel we are going. In one case we are considering selecting and adding in the region, so region was growing. In second case we are merging in the set, so region was growing. In third part, now we are splitting together. So we are separating them out. And then we divide region by region. So suppose one region is there, so we divide into four regions. Then R4 again divide in next four. Likewise we divide, and then finally we will find the